Hello everyone and welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 in November. So time zone 0. Question number 3. Stuff asking on also topic 1 stoichiometry, especially mole calculations. Let's see. Number 3. Which contains the greatest number of moles of oxygen atoms? So the focus on this question is obviously we should be focusing just on oxygen atoms and finding their moles, right? So basically, even though that the given number of moles is for something, but then is it for referring to the oxygen atoms yet? No, right? But just referring to the entire compound. So what should we do is like we should first translate all the languages of these moles of that entire compound to the moles of oxygen according to that formula, right? So in this case, we can see, right, for the first one, like A, given 0.05 moles of the magnesium nitrate, and given that in 1 unit of this magnesium nitrate, we see 2 nitrate ion, and each of the nitrate ion contains 3 of the oxygen atoms, right? So all in all, you can say in one entire unit, just like in 1 unit of this Mg bracket NO3 bracket 2, we can already see 6 oxygens. Makes sense, right? So that simply means you put the 2 inside, so let's say multiply by 6, right? So that means if I get 0.05 moles of this unit, at the end I'll be having this ratio to be done so as to convert the unit back to the entire units of oxygens, right? So that's why I will have now 0.05 times 6, so which is 5 times 6, so that is 30. 0.3 moles of oxygen. So that is choice A, right? So far so good, right? If you make this understandable, that is then for B is the same thing, right? We have 0.05 moles of this entire thing, right? But then for this case also 1 unit, this time we will be having entire unit for the C6H4 bracket NO2 bracket 2. These are all having oxygen just on the last bit, right? And the oxygen will then be 1 unit contains 2 of the nitrites, and then each unit contains 2 oxygen. So all in all, we get 4 oxygens, right? Simply multiplied together. And so that's why if we are given 0.05 moles of this entire thing, given 1 entire thing contains 4 oxygen, so all in all we get 0.05 times 4, so that will be 0.2 moles of oxygen. So that's why A is going to be higher. For C, that's easy because 1 unit this time only contains 1 oxygen. So that's why the ratio is still 1 to 1. So that's how many moles you have, how many oxygen within inside also to be the same number, right? Makes sense, because in 1 water we see 1 oxygen. So that's why with this in mind, 0.1 moles will then be times it by 1 as well. So also 0.1 moles of oxygen, right? And finally, right, with the 1 unit of this nitrogen dioxide, we'll see that 1 unit contains 2 oxygens. Right, so that's a given 0.1 moles also with this ratio 1 to 2, so all in all we get 0.2 moles of oxygen. So that's why all in all we should choose the highest number, and that goes to A.